Lord. Please be seated.
Thank you for the opportunity to be with you, and I guess I need to turn the mic on first thing, don't I? All right, testing, 1, 2, 3. Are we on? Good. I want to thank the elders for the invitation to bring this series of lessons to you tonight, and I want to lay the groundwork for what we're going to do. For tonight and tomorrow night, this is a science lecture hall, and I'm assuming it's okay with the elders for us to treat it like a class. And because it's a class, you are going to respond to me when I ask you to. Because I want you involved. And I'm going to work from down here both days because it's a class. And my goal, of course, is to get the points across to you about the magnificent God we just sang about. And thank you for singing that song so beautifully. How great thou art. My hope is when we finish this series of 3 lessons, which should be 16 lessons, that you will be in awe, even more than you ever have been. That's my goal. And I prayed specifically about that this morning, that God would grant me the words that somehow I could get through to every person in this audience, from the little ones all the way up to us oldsters, that we come to a deeper appreciation of who God is, because he's speaking to us in more than one book. So, that's the introduction. I expect you to be active listeners. I might add, I don't allow sleeping in my class. And I've taught a long time, and I can see you. So, if you had a big supper like we did, and I were sitting where you are, I'd probably start getting drowsy. And if that happens, then we're going to do something about that. Because I want your attention, because what we're going to talk about, in my mind, is to honor the great God who made us. So thank you for being here. That's my introduction as far as the introduction to the whole series. Sunday, we're going to turn our attention to biblical topics. And we'll focus 3 lessons on matters that relate to the scriptures themselves. I think that's the best thing to do, especially on the Lord's Day. But tonight, I want to turn your attention to God's other book. So you see the title for the lesson this evening? Science and Belief in God, Conflict or Coherence. I took my title for that from this book by Henry F. Schaeffer. So I want to see how many of you ever heard of Henry F. Schaeffer. Anybody? You think you know him? Yeah, he's a world-renowned chemist. Very famous man in the chemistry area. You know I'm a chemistry teacher, right? And mathematics. It's only the most important subject you'll ever study. And I know the subject you love the most. If you don't love it, it's because you didn't have me as your teacher. And I'm going to hopefully convince you of that also. But Dr. Schaeffer is a marvelous chemistry teacher. But what I love about him is he's a strong believer in God, and he believes Jesus Christ is the Son of God. Now, he's not of our fellowship, but he's a believer. And he's a believer as a world-renowned scientist. And in this book, it's really a summary of some lectures he gives on the college campus at the University of Georgia. And he's taught at a number of famous universities around this country. And he openly declares that there's testimony in the natural world for the existence of God. And there should not be conflict in people's minds between science and belief in God. And specifically, in his case, science and Christianity. And of course, I'm a Christian as well. I believe Christianity is the message that God sent us through his Son. So his point in this book is, if you think there's conflict, you need to read this book. Because there's a whole lot of scientists before now and presently who are strong believers in God. And don't you think otherwise. We'll talk about some of them tonight. But there's a whole lot more in this book. So conflict or coherence depends on who you talk to. There's an awful lot of scientists in our day who will tell you there is conflict. In fact, they cannot get along. Some would tell you, college teachers, that if you believe in God and you claim to be a scientist, you need to get yourself fixed. Because belief in God and being a scientist cannot go together. That's a very common theme in our time. So, that was a little bit of introduction to what we're doing tonight. We're in a church building, if you didn't notice. And when I give these lectures in a church building, it is important to me to start with some passages from the Bible. And I'll explain to you why. We're going to look at one from the Old Testament. That's the book of Psalms, chapter 19. And then we're going to look at one from the New Testament. Both of those parts of the revelation of God's will speak to the subject of this weekend. So Psalm 19, verse 1 says, "The heavens declare the glory of God, and the firmament shows his handiwork. Day unto day it utters speech, night unto night reveals knowledge. There is no speech nor language. Their voice is not heard, but their line has gone out through all the earth, and their words to the end of the world." What the psalmist said in that passage is, you can look at the natural world, and you can hear a testimony that's not spoken, but it's there. It's a testimony of the existence of a grand creator. So the Old Testament teaches that, in that passage and numerous others. But there's a key passage that I consider the key verse to this series, and that's in Romans 1, verse 20. So listen to this one. It says, "For since the creation of the world, his invisible attributes," that is, God's invisible attributes, "are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse. Because although they knew God, they did not glorify him as God, nor were thankful, but became futile in their thoughts, and their foolish hearts were darkened." That passage teaches, class, that you can see God, even though he's invisible. How is that? You can see him by the things that are made. And when you examine this world, and everywhere you look there's design, it sure looks like somebody made that. And that testimony should at least lead you to believe there's some being that is eternally powerful and that's not part of this universe, and who therefore is the creator. The observation of the natural world reveals characteristics of God. That's the argument. In fact, it's come to be called the argument from design. And so this evening and tomorrow, we're going to be talking about the argument from design. Design in the natural world speaks to the existence of God. And I'm here tonight and tomorrow to tell you that never in the history of mankind has that testimony ever been any stronger than it is today. You're blessed to live in this age. I'm deeply respectful of science. I've taught it for 35 years. I'm deeply respectful of what it's done for mankind. But I'm not deeply respectful of some scientists who have tried to take that and turn people away from God, because that's exactly the opposite of what they should be doing. So, the Bible says, please get this, class, the Bible says you the world and come to believe that there's a God. That's what Romans 1 teaches. That's what Psalm 9 teaches. So, there's biblical support for what I'm going to do this weekend. The Bible says the natural world speaks of God. So, for the rest of our time tonight, I'm not going to be using this book. Don't take offense at that. I'm going to use this book all day Sunday. But tonight and tomorrow, I'm turning our attention to God's other book. He's given us testimony in another way. And it's just as powerful in terms of convicting you of faith in God, as you will see, I hope, better than you ever have in your life. So, I'm not using God's revealed word tonight in that book. I believe it is his word. And I preach from it all the time. Tonight, I want to speak to you as a scientist and a science educator. That's my strength. And I want to tell you why I'm a firm believer in God based on that. So, many of the key scientists in the Age of Enlightenment, 1600 to 1800, the Renaissance we call it, were strong believers in God, in Jesus Christ, and in the Bible. You can read Dr. Schaeffer's book and find many of them. I'm going to share a few of them with you. Some of the greatest scientists that have ever lived were not only great scientists, but they were believers. Johannes Kepler. Now, how many of you in this audience have ever heard of him? One. He's not a very well-known scientist, but I can tell you he's one of the greats. He lived 1571 to 1630. He was an astronomer, and he's given credit with discovering the laws of planetary motion in our solar system. And he did it from observations made by himself and a number of others under very extreme circumstances. They didn't have the fancy stuff we have today, but he came up with those laws, and he's credited with that. But I want you to listen to this great scientist of past ages. He said, "I was merely thinking God's thoughts after him. Since we astronomers are the priests of the highest God in regard to the book of nature, it benefits us to be thoughtful not of the glory of our minds, but rather above all else of the glory of God." Don't you love that? Here's a scientist, deeply respected for the work he's done in that field, who says what we ought to do coming out of that is think of the glory of God, not the glory of our minds. I'm sorry that many scientists in our day are bragging on themselves rather than recognizing the majesty of God. Kepler wasn't one of those. He was also a great mathematician, by the way. But when he did his math, he had to do some very complex mathematics using logarithms. You remember your logarithms, people? Your favorite thing to do? Logarithms allow you to take complex multiplication and division problems and turn them into addition problems and subtraction problems. And he was good at that. But I think, how many of you heard of this one? Isaac Newton. Surely everybody in this audience. I think he surely must be the greatest scientist that ever lived. And I have reasons for thinking that. Independently, he helped invent the calculus, which I taught for 30 years. Only the most important class you'll ever take if you're a science math person. And if you don't know why, here's why. In calculus, you study infinity. And you'll never get closer to thinking God's thoughts after him than when you're trying to analyze infinity. And I wish I had a few more classes just to tell you about that. That's not where we're going. But this man not only understood the calculus, he invented it. And for thousands of years, we had lots of problems that could not be solved until calculus was invented. It has now changed the whole world. He formulated the classical laws of motion. Newton's laws stood for a century or two as the way to understand laws of motion. He invented and applied the universal laws of gravitation. You've probably heard of that. The whole story is he watched an apple fall from the tree, and out of that came his notion of what gravity is about. Here's what you don't know. Newton is credited with expressing the law of gravity mathematically. And if you can do that, you've reached the highest pinnacle of science. So coming out of that was a gravitational constant, which we have since learned is very finely tuned, which is part of our theme for tonight. But it's Newton who first discovered that. He pioneered studies of light and optics. He determined the speed of sound, and listen to what he says about our solar system. The greatest scientist that ever lived. Though these bodies indeed may continue in their orbits by the mere laws of gravity, yet they could by no means have first derived the regular position of the orbits themselves from these laws. Thus, this most beautiful system of sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. So says Isaac Newton. He was a deep believer in God. In fact, it is said he spent more time studying the Bible than he did science. I love that, because this man knew the sciences, and he honored God along with it. So if you were in college, young people, in the early 1800s, you would have very likely taken this class if you lived in Europe, and especially in England. It's a class in natural theology. Notice the subtitle, Evidences of the Existence and Attributes of the Deity Collected from the Appearances of Nature, by William Paley. It was a standard college course. Everybody took it. Another famous scientist you probably know is named Charles Darwin, took this class also and was deeply impacted by it. What you probably didn't know is that Charles Darwin went to school to be a preacher before he became a naturalist and changed his degree program, and he became a biologist instead. But he went to study preaching first, and it's because partly of this class. Well, the whole class was about how do you come to see God in the natural world. So, class, I want to pretend that you are in William Paley's class in natural theology. Welcome to class tonight, ladies and gentlemen. And if I may, since he was British, I'm going to use a little bit of British accent. So you're in my first class on natural theology. And the first thing he introduced was the watchmaker argument, and here it is. Ladies and gentlemen, had you crossed the heath recently and come across a stone which you kicked over, and someone were to ask you, how did that stone get to be there? It is highly likely that you might have said, well, I don't know, it may have been there forever. For all I know, there's nothing particularly important about it. He said, but class, had you crossed that same heath, kicked over the stone, and saw lying beneath it a watch, and then he would pull out his nice watch, which you examined carefully, and someone were to ask you, where did this watch come from, and how did it come to be there? It is highly unlikely you would give the same answer. Rather, you would say, this demands explanation. It is rather likely that someone made this watch and left it here by accident because there are too many features of it that show design. Watches have cogs and wheels that are interconnected, and when you study them carefully, you say, somebody designed that. And may I say to your class that when you examine the features of the natural world, you find many things like that far more complex and amazing in the natural world than any watch. And it should lead you to the same kind of conclusion. There had to be a designer for such as that. Well, with that beginning class, you then spent the whole year studying evidences from the natural world for the existence of God. And it was a powerful thing. Well, how is it that here we are now in 1980, the Cosmos series, did any of you ever see any of that? That was the most popular science program ever on television. Carl Sagan. And by the way, Carl Sagan was a professor at Harvard University when I was a student there in 1967-68. I didn't have him as my teacher, but he was there in the astronomy area. And I did take astronomy at Harvard, studying under some of the professors that rubbed shoulders with him all the time. Here's what Carl Sagan said in the first lesson of the Cosmos series. The cosmos is all that is, or was, or ever will be. That's how he started his science series. And may I say to you, class, that is not a scientific statement. There is no way science could demonstrate that. That is a statement of philosophy. Carl Sagan is a naturalist. He's a scientific materialist, or was. He's passed away now. He believed there was nothing else but the cosmos, that there was zero evidence for anything beyond the cosmos. And he started a science series with that statement. May I tell you, that's one of the most prejudicial statements I've ever read in a science lecture? First place, science cannot tell you that. Secondly, it's a statement that he believes so strongly, he thinks it's the truth. But it's a belief, not well supported. So how did we get there? From the 16 to 1800s to the 2000s and 2100s. And it gets worse. By the end of the 20th century, Richard Dawkins, 1941 to the present. How many of you have heard the name Richard Dawkins? Several of you. And the reason you have is because he was appointed by Oxford University as the professor of public understanding of science. In other words, this man has been given the role at Oxford to tell you common folk what science is about. And he's been given that title. So he is literally a spokesman. He's also come to be classified with three other men as the four horsemen of the apocalypse of the new atheism. And he's very outspoken. So I want you to listen to a couple of comments this man has made, trying to explain to you why you should not believe in God. In his book, The Selfish Gene, 1976, he says, you are people of faith. Faith is blind trust in the absence of evidence, even in the teeth of evidence. It is a process of non-thinking. That's what he thinks about people of faith. So I'm going to say something to you right now, and you remember this the rest of this series. Every position on origins as to where things came from is a position of faith. You're going to somewhere have to get off and believe it. But class, does God expect us to believe just like this? Just close your eyes and say, I believe, no evidence. Is that what God expects? Come on, do something. No, it is not what God expects. Our faith as Christians should be founded on evidence, should it not? Romans, the first chapter, Psalm 19, both testify that there's evidence in the natural world to believe. It's not blind faith, but that's what Dawkins thinks about it. And I can tell you I've been in debates with several evolutionists, atheists about this matter, and they cannot stand to be told they have a position of faith also. They don't like that. And this statement shows you why. But here's a worse one. In his book, The God Delusion of 2006, Dawkins said, if this book works as I intend, religious readers who open it will be atheists when they put it down. And see, what you're learning, if you didn't know it already, is new atheists are religiously motivated. They're evangelistic. Why would you want to be evangelistic to convince someone there's no God? I don't understand that one, but they are, because they want you to believe the same way they do. But here it gets worse. And by the way, before I put this up here, I want to make this comment. People on both sides of this issue sometimes say very ugly things. I don't want to be involved in that, nor do I want you. We need to be respectful, gracious, and kind, firm and solid, but not ugly and mean. And Richard Dawkins doesn't partake of that notion. So here's what he said in this book. God is a delusion, a psychotic delinquent invented by mad, deluded people. So any of you folks out here believe in God, he thinks you're a bunch of deluded folks that just believe in a crazy person that humans made up. Yes, ma'am.
May I propose a question to that?
I guess. What's your question?
What about the other end? What about them being psychotic delinquents?
Here's what I'd say to that. I would say this is more applicable to them than it is to believers, but I'm not going to say it that way because that's ugly. That's not very nice. In fact, it's mean. And it does no value. It has no value except to belittle. And look, if you're a believer in God, don't use that kind of technique, please. because it doesn't represent your God well. But that's the kind of things we're getting nowadays. And I can tell you in my classes, both at Florida State and at Harvard, I had professors who would say to the kids in the class, like me, if you're a believer in God, you better get over it. Because the more we learn from the sciences, the less we need God. Your God is just the God of the gaps. You stick God in your gaps of knowledge because you don't know how to explain things, so God did it. No, class, that's not what I'm talking about this weekend. We're not in the God of the gaps. The more we learn about nature, the more it testifies to the existence of God. Not because there's gaps. The more we fill the gaps, the more evidence there is for God. But let's not partake in what Richard Dawkins does. I'm ashamed of it for doing that. So how did things change so radically in 200 years? So for the next few minutes, I'm going to give you the fastest treatment of the history of science over 200 years in mankind's history. I took 3 classes at Harvard just on the history of sciences and mathematics to learn what the old thinkers thought. Marvelous classes. And there's a whole lot I could tell you. I'm going to share the tops of the mountain peaks to show you how we got here. Pierre Simon de Laplace, 1749 to 1827. He lived right during the time after Newton. He perceived of himself as the next Isaac Newton, and he was far from it. But here's what he said about the natural world, and particularly our solar system. Nature, with its matter, energy, and forces, could produce and maintain our solar system. We have no need for a God hypothesis, as Newton had said we do. So men like Laplace and others were coming along and saying, from the laws of nature that we understand, you don't need God to make things like they are. Nature by itself can do it. And that notion began to multiply. So Charles Lyell, in The Subject of Geology, Principles of Geology, in the attempt to explain the former changes on the Earth's surface by reference to causes now in operation. Here's how Lyell ended up. He said, you don't need any new forces or any strange things, any God in geological formations. You can explain them by things happening now over long periods of time. And by the way, that's a book that Charles Darwin read on his trip around the world on the Beagle and was deeply influenced by it. You need lots of time, class, if you're going to believe everything you see in this world came about by natural causes. Lots of time. And Lyell thought he gave it to you. And then the book Origin of Species, published in 1859. Notice the title, class. I don't know if you can read that. The Origin of Species by Means of Natural Selection, or the Preservation of Favored Races in the Struggle for Life. Did you know that was the subheading? It was. And what Darwin believed, and many still do today, is that what nature does is it preserves those races that should survive. Nature selects the ones that can survive. And the ones that survive ought to be the ones that dominate. Class, do you think that was used maybe in the 1940s, 30s, when Hitler was coming along and declared his race, the Aryan race, as the dominant race in the world, and declared then that there are other races which don't deserve to exist, which leads to killing 6 million Jews and a whole bunch of other folks you don't know about, because he killed way more than 6 million Jews. He killed lots of other kinds of folks too, who were really hurting the advancement of humanity in the favored races. And folks, I have to tell you, if you truly believe Darwin's theory, there's no reason to think otherwise. If you take that theory to its logical end, nature picks those that ought to survive, and I'm one of those, and you aren't. And there is no basis for saying there's something wrong with my eliminating races that don't deserve to exist. It's a horrendous thing for humanity. But it began to impact all of humanity. And I don't believe there's a book that's ever been written, not even close to the Bible, of course, that's the most important book ever written. But Darwin's book is second to that in terms of the impact it's had in this world. Because it has literally changed the worldviews of some of the leading lights in the sciences. And it's destructive. So there's no need for a designer to account for the origin of species of life. Natural selection acting on natural variation accounts for the appearance of design. Things look like they're designed, but they're not. Nature selected the variations that were best able to survive, and from that came everything. That's the theory. And it has swept the world. And then O'Perrin and Haldane came up with a thesis that there's no need for God to produce life from non-living matter either. So over the period of 200 years, we went from God being represented in the natural world to you don't need him anywhere. And that's where we are today, in the 20th and 21st century, on the minds of many. And I say, class, it's time to revisit the argument from design, because it's more powerful than it's ever been in the history of mankind. So, I brought a bunch of books up here. I brought them so you can see them yourself. I'm also going to provide you with a bibliography that has all these books in it and a whole bunch of other ones. So anybody in this class who wants to deeply dig in, there's lots of wonderful material. And if you want to check something I've said, you just ask me and I'll tell you where I got it, and you can go read for yourself. Don't you believe something because I said it. You go look for yourself. But these books, look, when I was at Harvard, I spent every spare minute in Widener Library trying to find something written by creationists that was worth reading. And I couldn't find anything. 67, 68. Now, here we are 60 years later, there is more good material written by strong scientists, well developed and well respected, that can support your belief in God. And don't you think otherwise. So I'm going to introduce you to a bunch of books that I hope you'll dig into if you like. So here's the next one we want to talk about. Stephen Meyer is one of my favorite authors. He's a great scientist, but he's also a wonderful writer and philosopher. Not many scientists are good writers. He is. And I call them his trilogy. He wrote Signature in the Cell in 2009. That's about the DNA we're going to talk about tomorrow night. Tomorrow morning. Don't miss tomorrow morning. By the way, are you recording this at all? Okay. If you have to miss, please listen to it. And then, secondly, he wrote Darwin's Doubt, which is about the origin of life. Darwin's biggest doubt was, how did life first get started? And the fossil record related to that. But his third one is the one I'll introduce you to tonight, the return of the God hypothesis. You remember Laplace said we don't need the God hypothesis. Meyer says you look at what we know today and you better revise that statement because it's just not accurate. So I'm going to show you what he says in this book. There are 3 scientific discoveries. The evidence has become overwhelmingly strong that the universe, space, matter, and time had a beginning. I'm pausing. If you were in my class, you would know that when I pause, that's going to be on the test. In other words, it's important. Science class in the last 150 years has come to point scientifically, forget the Bible. The Bible says in the beginning God created, doesn't it? But that's not the way science works. Science examines the natural world and comes to conclusions as to how it came about. And I'm telling you, the evidence of science today is powerfully strong that there was a beginning to this universe. Both matter, time, and space at some time didn't exist. Now, I'm not going to talk about that in this series this weekend. That is really heavy stuff, but there's plenty of material in here for you to study for yourself. Evolutionists do not like that. They want matter to be eternal. Then you don't have to explain how it got started. And matter produced everything you see here, but you don't have to explain how it got started. Now you do in science. And it's a problem. So that's the first thing. Second, the universe, our solar system and Earth are remarkably fine-tuned to support life on Earth and have been since its beginning. Things are fine-tuned, class. That's my topic for tonight. And I'm going to cover it as much as I can this evening. But there's a third thing. Even the simplest forms of life at the biochemical level contain massive amounts of digital information being used to produce and maintain an untold number of molecular machines and complex processes. I know I lost you on that one. What that's saying is, down at your cellular level, inside every living thing, there's a massive amount of information that's being used a lot to do incredible things. That's tomorrow afternoon and tomorrow morning. Don't miss it, because it's overwhelming. And those three things that have been discovered massively in the last 70 years are powerful evidence for design. And that's what I'm going to talk to you about. So, that's my introduction to this section. This is a book you ought to look at if you're interested in digging in. All right, so next, we're going to talk about fine-tuning. Everywhere you look, things are fine-tuned. So, you're in my class, you're going to answer some questions for me, and I'm going to help you out. The answer to almost all of my questions are just right. So you be ready. Paul Davies, in a book called The Goldilocks Enigma, Why is the Universe Just Right for Life? Paul Davies is an atheist. He does not believe in God. But he has to admit that everywhere you look, the universe sure looks like it is just right for life. It's the truth. One of the most significant facts, arguably the most significant fact about the universe, is that we are a part of it. Would you agree, class? We're here. How'd we get here? And then he says, everyone agrees the universe looks as if it was designed for life. Class, what I'm here to tell you tonight is, if things weren't just right, you wouldn't be here. Period. And there isn't a court case you'd ever want to take where you have a prosecuting attorney and a defense attorney that they wouldn't be saying the same thing about this. Because the evidence is overwhelming. And I want to share just a little bit of that with you. So kids, help me with Goldilocks. You kids in the back, what do you remember about Goldilocks? Come on, help me. She was a girl that went what? Help her, adults. Where did Goldilocks go?
Breaking and entering.
Huh? Breaking and entering, yeah, thanks. She went out into the woods and she broke into a house, right? The house of the three bears. And she sat down at the table and there was a bowl of what? Porridge. She tried it out and it was too hot. And then she went to another bowl and it was too cold. And then she went to the third bowl that was the little baby's bowl and it was exactly right. And didn't that happen over and over again? She sat in the chairs and then she laid on the bed and finally she reached one that was always just right. Yeah. That's why he called this the Goldilocks book, because that's what you see in nature. Everywhere you look, things are just right. So, the really amazing thing is not that life on earth is balanced on a knife edge, but that the entire universe is balanced on a knife edge and would be total chaos if any of the natural constants were off even slightly. Everything has to be. That was weak, class. Let's try it again.
Just right.
Yeah. In nature, everything has to be, or you wouldn't be here. It's exactly right. So let's illustrate it. In the 1960s, when I was in college, scientists had discovered 12 characteristics of the cosmos and our solar system fine-tuned to make human life possible. 12 is not a big deal. You could have 12 coincidences, I think. But I don't know how you feel. How many can you put up with? How many coincidences? Can you say, well, isn't that interesting? It just happened that way, and it happened that way, and it happened that way, and it happened that way, and all these fall together. Don't you reach a point where there's too many coincidences? The evidence becomes overwhelming. So let me show you what's happened since the 1960s. By 2020, there are at least 50 books published documenting the anthropic principle, which is things look like they're just right for life. Anthropos is the word for us. And the anthropic principle is the properties of nature sure seem to point to our existence. And they're just right. How many of those can you have? A lot. Hugh Ross and his staff has taken these 50 books and they've cataloged over 800 fine-tuned characteristics as essential for any potential human life site in the observable universe. That's why, class, you now are getting books like this one. You see the title? Rare Earth. These are atheists. But they are saying in this book, it is likely that there's another place in the universe, just like our Earth, that supports life like we have it here. It's extremely rare. Why do they say that? Because the more we learn, the more everything has to be exactly right. You're still weak, class. I want more enthusiasm because it's the truth. This book would not have been written 100 years ago. Carl Sagan in the 60s believed there were enough intelligent civilizations in the Milky Way that there were probably thousands of them, which is why the whole movement got started searching for extraterrestrial life. And we got a movie called E.T., didn't we? It's because they truly believe there are lots of civilizations like ours or even more advanced. Well, I'll tell you, a lot of folks aren't believing that anymore. The more we learn, the less likely it is that there's another place anywhere in the universe besides this one. Here's another really fascinating book called The Privileged Planet by Guillermo Gonzalez and Jay Richards. I met these gentlemen a few weeks ago. Strong believers. And this is a compendium of evidence that we are a privileged planet. There's not another one like it. And not only can you find evidence for design here, you can find evidence that we're the ideal place for observing the design. It's amazing. There's another good book for you to read. All of it fits together under the same general theme. All right, so what do you think? 12 characteristics or 800? I'm not sure everybody would agree with the 800, but there's at least hundreds of features that all have to be just right. So, here's what I want to do with you next. Here's my next book I want to introduce to you. Now, if you're a mom and dad of young kids, this is where you need to start. It's called God's Crime Scene. It's by J. Warner Wallace. J. Warner Wallace was raised by parents who were atheists. His daddy is a detective. He became a detective also. And he was an atheist until he became convinced by the evidence that was overwhelming. There has to be a God. And so he calls the universe God's crime scene. And so in this book, every chapter is a description of something he's discovered while he was a detective. So chapter 2 in this book is entitled, let's see here, that's chapter 3. The title of chapter 2 is Tampering with the Evidence. Who is responsible? And it's built around a court case. So here we go, class. I'm going to read you just a little bit of this. Helen knew something was wrong when her daughter Carrie failed to answer the door. It was a bright summer afternoon. Carrie said she'd be home. Her car was indeed parked in the driveway. Helen tried to peek in through the living room window, but the curtains were unusually drawn. Carrie never locked the back door, but when Helen walked into the backyard of that old house, she found the door locked and all the windows closed. Carrie never closed that one badly worn rear window, but it was closed this time. Helen began to panic. She knew Todd and Carrie had a tumultuous marriage, one that included physical violence. Todd had moved out, but Helen still feared for her daughter's safety. The couple had a child named Lexi, but the violence had only intensified since her birth. A week ago, Todd had threatened to kill Carrie. And just last night, Carrie confided to her mama there had been another fight. That's why Mama came to see her this day. When Helen could not get Carrie to answer the door, she called the police. And that's the beginning of this case, tampering with the evidence. Well, I'll not read all of this, but I'll tell you what happened next. The police came. They got in the front door, and there was so much smell of gas they had to get out and bring the hazmat team. When they finally got it cleaned out well enough and were able to go upstairs, they found a number of strange things. The door at the bottom of the stairs was closed, and there were a bunch of clothes piled up at the bottom. Carrie never did any such thing. When he got to the top of the stairs, there were 2 dead bodies in the bed, Carrie and Lexi. And the gas smell had come from an open gas thing upstairs. Those people didn't use gas normally. And the final straw on the camel's back was when they discovered that Todd had gone to the gas company that same week and had the gas turned back on, which hadn't been on for a long time. And when they found the gas open, all of that collection of evidence, background evidence, foundational evidence, regional, locational. The question was, did those 2 die in that house by natural causes, or did somebody tamper with this? And I will tell you the end of the story, class. Todd was convicted of first-degree murder of his own wife and baby, and nobody observed it. He was convicted by the combination of circumstantial evidence that all piled up that it was impossible to explain any other way. Now listen to what he does with that. We were compelled to examine the evidence of tampering because of one important fact. There were 2 dead bodies in the crime scene. In a similar way, when we look at the nature of our universe, the existence of living bodies ought to provoke an investigation. Wouldn't you agree? How did all these living bodies get here? What's the answer to that? Did that come about by natural causes, or did somebody tamper with this? Like our murder scene, there are foundational, regional, and locational conditions demanding explanation. The foundational laws of physics, the regional properties of our solar system, and the locational conditions of our planet resulted in our existence. But did this have to be the case? If circumstance had been slightly different in Carrie's house, those 2 people wouldn't be dead. If circumstances on our earth had been just slightly different, we wouldn't be alive. So how do you account for that? I will tell you, J. Warner Wallace came to believe the evidence is overwhelming. Somebody tampered with this. This did not happen by natural causes. It's better explained because somebody designed it. And the evidence is powerful, folks. You need to read this book. And you need to read it with your kids. And grandkids, by the way, since I see some hoary heads in here. And some heads with no hair. So, in that chapter, he outlines some specific laws of nature, physical constants, properties of elements and chemicals. that all have to be, class? Just right. Exactly. Or you wouldn't be here. So I'm going to give you one. There are hundreds of them. The ratio of protons to electrons in atoms is a very finely tuned number. And if that ratio was off just a little teensy bit, you wouldn't be here. And everybody knows it. Well, let's talk about a number here. And I don't like to use these huge numbers very much, but I think you ought to at least know this one. The ratio of electrons to protons must be precariously balanced. If the value of this ratio deviated by more than 1 in 10 to the 37th, that's 10 with 37 zeros. Out of 10 to 37 zeros, if you change one thing out of that, you wouldn't be here. That's the truth. So what is 10 to the 37th? Here's his illustration. Imagine covering the entire North American continent in dimes and stacking them till they reach the moon. Are you with me? The North American continent stacked with dimes to the moon. That's 250,000 miles away. Now imagine stacking just that many dimes again on another 1 billion continents of the same size as North America. If you marked one of those dimes and hid it in the billions of piles you'd assembled, the odds of a blindfolded friend picking out the correct dime is approximately 1 in 10 to the 37th. The same level of precision required in the balance between electrons and protons. Would you say that's just right, class? Think of this picture. Here's a machine that's going to make a universe. It's got all kinds of dials on it. Every dial has to be just right. So this dial is exactly at some number, like the universal gravitational constant. It's a precise number, class. If you change that number just 1/10,000,000th, you wouldn't be here. If you change the ratio of electrons to protons 1 in 10 to the 37th, you wouldn't be here. And there's hundreds of these that all have to be, say it, just right. Or you wouldn't be here. There would be no life. You have to be in the right galaxy. Now we're going to go to regional areas. Our galaxy has to be just right, class. You can't just have any old galaxy. So here's the James Webb Space Telescope, put up there in 2021. And what you're going to see now is the first picture released from that telescope. Our President Biden released that picture in July of last year. So, lights? Guys, are we ready? Before you turn them out, just get ready. Don't turn them out yet, because I need to do one more thing. I want to read you this. This is the NASA Webb delivers the deepest infrared image of the universe yet. This is their announcement about the picture I'm about to show you. Webb's image is approximately the size of a grain of sand held at arm's length. Everybody's eyes up here. Take a grain of sand, put it in between your fingers, and hold it up here at arm's length. The amount of the universe that is blocked off by that grain of sand is what's in this picture. Did I lose you? Let me say it again. The universe is huge, would you agree? You're only looking at one little tiny piece of it. It's the amount blocked off by one grain of sand way out there. We've never seen it before till this telescope. So what you're going to see a picture of is that little teensy bit of the universe. Did I get that across? Do something with your head. All right. I want that clear in your mind because I want you to see this picture in the dark. You don't see the sky well enough. There's too much light around. So go. Lights off. Exit lights. That's not good. You can't turn them off, can you? That's not allowed. Oh well. That's the best we can do. That's called Galaxy Cluster SMACS 0723, the James Webb Space Telescope, July the 12th, 2022. I'm going to just let you look at that a minute, class. You see that glob right there? And that one? And that one? You say, that's an amazing star. Look at these stars. No, class, that is a galaxy. So is that. So is that. All of these bigger globs are galaxies, which probably have in them billions of stars. And we've never seen this before. This is all in that space subtended by one grain of sand. Because never had a telescope could see that far. So look here. That looks kind of like a glob, doesn't it? Can you see this one right here? It looks more like a spiral. See it? That's a spiral galaxy. There's another one right there, or close to it. It's kind of a rough one. But there's all kinds of galaxies in here, class. Galaxies. The amount of stars in the universe is so massive they can't be counted. And more we learn, the more there are. Let's get the lights back on. Should that be a surprise to Bible believers, class? That there are a lot of stars? Why not? Because what did God say to Abraham, for example? Your descendants will be as stars in the universe and the sands of the sea. We should have massive amounts of stars. But what you need to know, class, is not just any galaxy will do to support life. Elliptical galaxies won't work. There's a lot of reasons for that. Read the book. Irregular galaxies certainly won't work. No, what you need is you need to have a spiral galaxy if you're going to have life around a solar system like ours. And everybody knows it. Yes, ma'am. Yeah, what do you think our Milky Way galaxy is? It happens to be a spiral galaxy, yeah. It's one of those coincidences. Everybody knows, class, now that the other galaxies don't work. That means you've eliminated most of the galaxies in the universe as a place you're going to find life in a solar system like ours, advanced life like we have. You have to be in a spiral galaxy. But by the way, it's not just any spiral galaxy. It has to be a, what do you think? Just right spiral galaxy. Yeah. And there's a whole thing about the spirals themselves that have to be just right. For example, the location of the galaxy. If our solar system were sitting right there in the middle, this is a side look at our Milky Way galaxy. That's a bulb in the middle. If our solar system were sitting right there, it would last a few seconds. The gravitational forces and the other kinds of forces present there are massive. You couldn't have a solar system like ours. In fact, in our galaxy, there's only two spots where you could have a galaxy or a solar system that would work. They're right there, these two spots. Guess where our sun and its planets are? Right there. That's another good coincidence, class. But we've learned from other things that the place in a spiral galaxy to have a solar system is in these regions here. That's only about 1/150th of the total volume of that galaxy. So we've eliminated 149 out of 150 places in that galaxy. And class, we're just beginning. You have to have the right kind of star. You think just any star will do, class? No. Our sun is a very special star. It's huge compared to our planets, isn't it? But you probably didn't know this. There's our sun. Here's Sirius, the dog star, and Pollux, and Arcturus. And watch this. Here's Rigel, Aldebaran, Betelgeuse, and Antares. And where's the sun? Can you find him? He's right there. I can't see him from here. The sun takes up 1 pixel compared to Antares. Did you know the sun was a small star relative to Antares and lots of other stars? Did you also know, class, there's a whole bunch of stars smaller than our sun. They're called dwarf stars. And what do you think? Our sun is? Exactly right. And it's not only just right in size, it's right in temperature and radiation and a whole bunch of other features, all within a very narrow range of variability, or you wouldn't be here. So that's another one. How about the location of the planet? You think just any planet will do anywhere? No, class. What do you think about Jupiter? Is anybody looking for life on Jupiter? No. It's too massive. There wouldn't be any life there. How about the other big ones? Saturn, Uranus, and Neptune. Nobody's looking for life there because they know it's impossible. How about Earth? Well, it happens to be just right. This one that's the next closest to us is what? Does anybody know? No, it's not Mars. It's Venus. Is anybody looking for life on Venus, class? No. Anybody know why? Yeah, that place gets over 900 degrees Fahrenheit, and it has one of its major features in its atmosphere is sulfuric acid. Not helpful for living things. And by the way, it rotates backwards. It's a stupid planet. But whatever it is, it has features that would never support life, and nobody's looking there for life. Where are we looking? We're looking at the next largest one, Mars. And we're having trouble finding even the slightest hint of what? Yeah, but what are they looking for on Mars? Water! Class, if you were in my chemistry class, we'd be the next 6 weeks talking about nothing but water. It's the most incredible substance in the universe, and life absolutely depends on it. And you can hardly find any anywhere in Mars. And how much here on this earth? It's only 70% covered with water. And did you know you're 60% water? So when your brother calls you waterhead, he's right. Not only does the planet have to have the right size, it has to be in the right location around our sun, in a habitable zone, which means it has to be. Are you getting tired of this? Yeah. Easy test, right? In addition, there's a whole bunch of locational factors. The proper mass, the spin, the tilt, the moon, the atmosphere, the crust, all of those features of the earth. A lot of them. You know how important our moon is, class? We have one moon. One. Sunday night, I'm teaching Sunday morning in Bible class, I'm teaching a Bible lesson, but I'm going to end it with some more science. And it's going to be about the trip to Pluto. And by the way, Pluto's still a planet. So here's your assignment, class, for Sunday morning Bible class. I want you to come back to me and tell me how many moons Pluto has. It's the smallest planet in our solar system. So you go look it up. I want the moons and I want their names. Sunday morning Bible class. The fact that we have one moon is incredible, and it is also, that's right, in a host of ways. But in addition to that, there's properties of biochemicals, cells, genetic code, molecular machines. That's tomorrow. Lots of them. Every one of them has to be finely tuned, or you wouldn't be here. There's the cell. And here are some of the distances, and I'm not going to talk about that tonight. Molecular machines, I'm only introducing to you the idea that there are machines made of proteins that can convert chemical energy and produce linear and rotary motion that control many biological functions. There are thousands of machines in every cell in your body, class, all functioning at enormous rates, or you wouldn't be alive. Myoglobin is one. Kinesin and Dianine Walkers. Here's assignment number 2. I wish you could take a minute and go to the website and look for a YouTube on the Keynesian walkers, these guys right here. It's called A Day in the Life of a Keynesian Walker. And it's a cartoon. And you old people would love that too. I wish you'd go look at that. Because it's an illustration of a machine that does amazing things that we've only known about in the last 20 years. And there are lots of other ones. There's a picture of a Keynesian walker. See this little guy right here? He walks along microtubules and carries stuff way heavier than he is. Keynesian walkers. They carry stuff from place to place all over the cell. And if they didn't, you'd be dead. Extremely important. Don't have time to talk about those tonight. And we're going to even skip this one tonight because it's getting so late. But let me tell you what I would have shown you. This is a video of cell division. Do you know, class, how many times you make cells in your body every day? Have any idea? Thousands. How about billions? I know. Your body produces, well, let's just put it this way. Your skin sloughs off 40,000 cells every second. Kids, that's why you need to take a bath. Because dead skin is coming off all the time. 40,000 per second. That means they have to be replaced. 3 layers down in your skin, you're making cells every single second. And they do it by mitosis. One cell divides into 2 exact copies. And I'll tell you what we've learned, class. Involved in that process is a whole lot of molecular machines making it happen. And I don't have time to show it to you. So we're going to move on. Because I want to close by introducing you to this gentleman. His name is Dr. James Tour. He's a world-renowned nano engineer at Rice University. My Marilyn and I got to go meet him a few weeks ago. And it was a precious experience. He is a Messianic Jew. You know what that means? That's a Jew who's come to believe Jesus Christ is the Messiah. And he openly says that. And he's one of the most famous nano engineers. You know what a nano engineer is? A guy that works at the level of 1/1000th of a meter. And he does experiments and builds things. He's amazing. An open proponent that there is a God whose Son is Jesus Christ the Messiah. And he will tell you, if you want to become a Christian, you need to become a believer in the resurrection of Jesus from the dead. And he has it on his website. I love that. But there's a whole lot more about this man. See, he's helped invent graphene and its use, which is a 1 layer of carbon. And he's found all kinds of interesting uses. The guy has 150 patents, and he started like 6 new businesses. Busy. Brilliant. One of the things he did with graphene is he took this little mouse and he severed his spinal cord. And then he injected in there graphene and some other materials and closed it back up and let that rat go in the lab. Over a period of weeks, the lab rat regained his function 80% after having his spinal cord severed. Amazing stuff. This man is making a difference in this world. He's a believer in God. He also decided with his team at Rice, since we're doing all this nano stuff, we surely ought to build a nano car. So they designed a car made out of 1 molecule. See the wheels? And these are the axles, and this is the drive shaft. It rotates around, and that's what makes it move. You can move it with light, or you can move it with chemicals. And several people are working on this. So much so that they decided if we're all building nano cars, we ought to have a nano car race. Of course. So they did. April 28th and 29th, 2017 in Toulouse, France, the first international nano car race. And you can see there were 6 teams, the Austria-U.S. team, this is the one Rice was in, France, Germany, Japan, Switzerland, and Ohio University here in the United States. And I'm happy to tell you, class, that at the end of that race, the Austria-U.S. team won the whole thing by going 150 nanometers in 1.5 hours. A nanometer is 1/1000th of a meter. I mean, that's whipping along there, isn't it? For a nano car, that's moving. Look what number 2 team did. Switzerland went 133 nanometers in 6.5 hours, and everybody else gave up. What does that illustrate, class? It's hard to make nano cars, period. But Dr. Tour knows how to do it. And so when that race got over, all the rest of these people said, "Are you going to publish what you discovered here?" He said, "I already have, and you can have it." And he's going to hand it out. But before I show you that, watch this. His first round of nano cars was this one here. The first generation had a machine here that, see this rotor here? This thing can turn at 1.8 revolutions per hour. In other words, you're going to take an hour to go 2 times around. Obviously, that car's a total failure. So they generated a second generation over here, and I want you to notice there's only one difference between this car and this car's rotor. You see that S right there? That's a sulfur atom, and this is a 6 ring with 5 carbons and 1 sulfur. This is a 5 ring, and with that one change, this thing went 3 million revolutions per second. That's what won the race. But class, you know how they discovered this second one? They had to start all over. They didn't know that's what they had to do. This is tough. To build something this intricate is tough. So here's what Dr. Tour said. The nano cars built by Rice University were much smaller and far less complex than the kinesin and dynein walkers and other molecular machines common in every living thing. He said, our cars are nothing compared to what nature does. The Rice team had been working on nano cars for 20 years. Every molecular machine in living cells is much larger, at least 10,000 times, much more complex, and much more sophisticated. Dr. Tour says there is nothing we've done that even touches what nature does. And here, class, as a taste for how much work and intelligence it took to build a winning nano car. So I want everybody's eyes up here. Don't you miss this, class. Let's wait just a second so nobody's eyes miss this. What I'm going to show you next is the first page of his treatise on how he built that nano car. You ready? Here we go. I'll give you just a minute to read that. Here's page 2. No wonder none of the rest of those guys did it. This took years. And what you don't know is that this tetrahedron published his article in May 18 of 2017. That's the next month after that race. And it has 281 supplemental pages besides those 2. So what am I saying? Look how much work and intelligence it took to build one stupid little car that runs around on gold foil. Incredible. And he himself would testify to you if he were here tonight. My car, which we worked on for 20 years, is nothing compared to one out of the thousands of machines in natural cells. They do amazing things, way better than anything we've done. Folks, mankind hasn't touched what nature's already done. And nobody in their right mind would say a nano car, isn't it interesting how that evolved by natural causes? Nobody would say that. We know nano cars were designed by intelligent human agencies, don't we? Is anybody doubtful about that? Living cells with all of their thousands of nano machines, which are far more intricate, complex, interdependent, and full of digital information, were surely designed by a massively more powerful and amazing God than that. So, is there conflict between science and belief in God? No, class. Romans 1 says, examining the things in nature which the shows we're clearly designed lead us to believe in God. That's what the testimony of the natural world is. The Bible says so. And science shows us that everywhere we look, from the macroscopic to the microscopic, things look like they're made. There's design everywhere. Because, folks, to have life here on this planet, everything has to be just right. So is belief in God reasonable in this scientific age? It has never been more reasonable in the history of mankind. The evidence is overwhelming. And we ought to be on our knees in praise of the God who made us. And that's the lesson for tonight.